I'm Andre Pesh. I'm a director on the software engineering team here. I spoke at Tech Field Day 3, we were mentioning before, so it's exciting to have you guys back here. I guess what we want to do here is kind of make this a little bit more real, talk about one aspect of the CloudVision portal, really focusing on the network provisioning part and how we can really automate things for that large set of customers that Jeff was talking about. Definitely please, jump in, ask questions, make this as interactive as you'd like. So I guess to kind of set the stage here, as Jeff was saying, we're really trying to provide that kind of automated, that network automation, that cloud automation for the large tail of customers who have maybe not gone as far down that path. And there are really three main parts to this that I want to kind of harp on here as we go through this demo. So one is the notion of the network database, right? We have to get to this point where you have a single point which defines what you want the state of your network to be, right? You can't have and it has to be a network-wide view. It can't be, I've got this config file for this device that I've then copied and modified for this other device and done that 1,000 times. Now you have all these files you have to manage. You need that central point that defines what you want, because that's also that point that you're then going to go and say, okay, well, what's the current state of my system? And does that actually reflect, is that compliant with what I want it to be? The second part is we need to enable customers to make changes on their network without ever having to go and touch their boxes. And I think it's important that you do actually need the ability to go to your devices and make changes and debug problems as they happen. But when you're making routine automation changes, you need that framework to be able to go define your change, get it approved, and push it across your network in an automated way with checks and balances and visibility along the way to give you the confidence that the change you thought you wanted to make has actually happened. Right, so it's not just about having it happen automatically. You need the visibility into the fact that it's actually there. And a lot of this comes down to what are the APIs that we expose on the EOS level that really make this possible. And these are the APIs that we've been building over many years with our largest cloud customers that they've been leveraging to do this in their environment. And so now we're trying to bring that into a turnkey solution for the rest of our customers. And then the third part is knowing that customers have their own investments that they've made in various products already, whether it's their own config management database or task orchestration systems. And we're one piece of that larger data center orchestration problem, right? As people are rolling out new infrastructure, new services, there are a lot of different changes that happen across different parts of the infrastructure, not all of which we control. And so we need to be able to integrate with those pieces, be able to take information over, via API calls or whether entered by the user, and provide that end-to-end solution for the customer, where we're really doing what we do best, which is the network management piece. So with that, I'm going to go in. I'll stop this a couple times for questions, but I'm going to go in and give you a brief overview of kind of what we have here. So here we are on the kind of home page. You got access to a couple different apps, and I guess the main thing I wanted to talk about here is this service dashboard. This is where we pull in information from Arista.com to be able to give you information like, hey, this new software release is out, there's a new P-cert, there's a new field notice, and it'll bring that to you at the customer site. And so if we go to the network provisioning page, what we see here is all the devices managed by the CloudVision portal. So in this case, we have all these devices that we can then arrange into what we call containers. And these containers really provide us a way to group devices in a way that makes sense to you logically. So you'll see here that we have a container for the different data centers. Within each data center, we have a container for each pod. In this case, I've actually created a container for each availability zone within each pod. So if I have availability zones across racks for OpenStack deployments, I can create a different container for that. And this hierarchy then gives us the ability to place configuration definitions or properties at more than just a device level, right? Because if you think about what's happening when you manage your devices, if you look at a config for a device, 90% of it is the same for every device. Probably 99% of it is the same if you have like a simple templating algorithm, right? The notion that your network, each device is a snowflake, hopefully is long gone, right? You're trying to build large-scale networks that are highly reproducible, where you have a design, you stamp it out. And so when you're in that environment, you need to be able to take the configuration that you're applying, not to the device, but to a property that is associated with that device based on where it is, and have that configuration then get applied. So by reducing that, by creating this hierarchy, we can apply configuration at different levels and reduce that duplication that otherwise happens. I think the other important point to talk about here is this undefined container. So these are all the devices that have come up in zero-touch provisioning mode. So the standard way that boot up is kind of like pixie booting a server, right? You boot up, you DHCP for an address, you get a boot script, and as part of that boot script from the CloudVision portal, you register yourself with the CloudVision portal, and then you wait for configuration. So now, whether you're doing ongoing config management or your initial provisioning, you're rolling out new racks, you can do all that configuration from one place. It's not a separate process. And so these devices here now can get placed in the appropriate containers, applied configuration, and bootstrapped, all without ever touching the device, right, from their initial plugin. So finishing up on kind of the basic attributes of the CloudVision portal, the other thing, so if we look at the tenant container here, you can see some of the configurations that we've defined. We call them configlets. They're really subsections of config, and we'll talk about these in a little bit more detail later. But you can see here at the tenant level, we've defined that the AAA configuration, the eAPI configuration, some basic network and time zone configuration, these are the same across everything that I'm going to put within this tenant container. And similarly, I can add configuration at the different levels. And this is what's going to allow me to enforce that at a high level, everything should be the same in this way. Within this data center, these properties are the same. Within this availability zone, these properties are the same. And that's a really important way to reduce duplication. The other piece here is that we can tag every device. Some of these are automatic, and some of these are by the user. So here I have every top of rack in data center 1, pod 1. And then that was the list view. This is now a logical kind of hierarchy view where you can similarly filter on these labels. And so as the number of devices that you're managing grows, right, as you have hundreds of devices being managed, you can actually go and quickly filter down to what you're looking to make changes on, see the state, make the changes, and go from there. So that kind of covers the basic pieces. What I want to do now is put it all together and kind of go through one example. But maybe before doing that, is there any questions that pop up as we go here? All right, I'll keep going. So
containers, were you saying that there's like a parent-child relationship with spine and leaf? So if you were to make a configuration change, anything that's in that container and a child of it would also get that?
Yeah, that's a good point. Right. So the containers are a strict hierarchy. Labels are not strict hierarchy. Labels can be applied. You can have multiple labels on a device, and there's not kind of an enforcement that if you have this label, you don't have this other label. That's applied by the user. The containers are strict hierarchy, which allows you. I think the easiest way to think about it is based on location. Right. I think the data center pod availability zone model works pretty well because that's kind of how configuration is applied. And yeah, you inherit from top down. Things that are closer to the device or the device itself can override what happened above. But basically, the configuration of one device, and we'll see this in a sec, is really all the configuration from the tenant, or from the top level container, then all the child containers going down, and then what's applied to the device. And so in general, what's applied to the device is really just the stuff that's device specific, right? It's the IP address that you're going to get, right? It's maybe, depending on your environment, that may be most of what you have. Maybe some port-specific speed configurations. But in general, a lot of it should be at the container level. And with templating, you can actually put even more at the container level and just apply a template with specific individual, kind of device-specific variables filled in.
Thank you.
So for this example, what I want to do is actually go through kind of a common thing that we have to do at the networking team layer is go and apply a new ACL across your environment. And this is one of those things that we don't talk about as much because right now we talk a lot about integration with SDN controllers and orchestration systems and what do you do as virtual services move across your infrastructure. And that's really important. That's what CloudVision does too through our integration with OpenStack and VMware NSX using OVSDB and similar technologies. But it's equally important for the networking team to be able to make those underlay changes in an automated way so that as vulnerabilities come up or as changes need to happen or as you're rolling out more racks, you can just as easily provision and monitor what's happening on your infrastructure. So in this case, we'll look at the configlet page. I've already created this configlet. It's called the server port ACL. This is all of my server facing ports have this ACL applied. You'll see that this is just CLI, right? This is not trying to teach you yet another data model. This is for network engineers to know how to use immediately. And we can go and validate this across devices using eAPI so that you know this is tactically correct. And one thing you'll notice is this configlet is not associated with any device. It's just, it's there as a subsection of config. But then we can go and apply that at, for example, the data center 1 pod 1 layer. And what we're saying here is we want all of the devices within this pod to have this configuration. And so when we save this, one important thing to note is we haven't actually touched the devices. This is configuring our intent that we want this configuration across all of these devices. And you'll notice there's this pending task for actually running these. So there's a whole task management system for actually approving when tasks can actually get run. Because the definition of what you want to do and when you actually want to do it are separate things. And if we go here and look at the config for a given device, we can see that on the left there are the configlets. On the right, or in the center, there's the design configuration, what the configuration will look like when I push this, and on the right is the actual running configuration of the box. And I'm going to pause this here because I think it's really important to understand what's happening under the covers here. If you look at a lot of config management systems, there's this whole dance you have to play of like, this is my config file from before, and this is what I want it to be, and let me diff them and figure out what commands do I actually need to send, and oh, but I'm on this type of device and I actually need to send these ones before that ones, and it's just a mess, right? This is where we're able to leverage the APIs we provide. So eAPI, or JSON-based API, and config sessions, which are templates at the CLI, transactions at the CLI, to be able to say, look, here's the full configuration. I want the configuration of the box to look like this. There's no diffing on the CloudVision portal side. It just says, you've told me this is what you want the config to be. Here you go. And the trick is, by leveraging our system database, we're able to apply, we take a snapshot of the existing config, we roll it back to the clean state, we reapply all this config, and then we copy the database back over. And in doing this, we only change what actually is different based on the new configuration you're pushing. And so from a system perspective, if you have all these agents running around, they only see the difference. So in this case, you'd only see this new ACL. Nothing else changes. But from a complexity perspective, I know that the configuration is exactly what I want it to be. If it fails, nothing changes, right? That's the other thing that is terrible about automation is like automation is great until it half worked and didn't quite apply, and then how do you get out of it, right? So this is an all or nothing push, and by doing this view, you can see that there's also nothing there that you're going to get rid of that maybe someone put manually. We have a whole reconciliation process to be able to say, hey, there's actually a command that someone put here. Are you sure you want to blow this away, right? I don't think it should be there, but maybe you think it should. So I think this is a really important part of kind of the power of the APIs we provided, and then how we then leverage that to do automation in a much simpler and cleaner way. And so if we go here, now we'll go to the task management page, assuming I've hit play again. Yep, I have. The task management page, and you'll see the pending tasks. There's one per device. And now you get to decide how you want to apply the configuration you made, whether you do it all at once, whether you do it one at a time, and do checks in between, right? But now you have that control of how do I get these tasks approved, how do I run them, and how do I make those changes. Maybe you still have an outage window, or a change control window to do it when at a low peak time, but you can now do it all in an automated way, and with confidence that after this is done, it's actually fully complete. And part of what we provide here, and this is again the challenge of automation, is the whole compliance checking aspect, right? Because you want to know that what you think should be there is there, and that someone hasn't gone to the switch and changed it when you didn't realize it, and now you're at risk of losing that configuration. So compliance checking is really important. I think the final thing I want to talk about is everything we've done here with the UI is actually built on top of the JSON APIs provided by the CloudVision portal. So there's nothing that you can do manually that you can't automate. And this is really important because, again, our customers have made investments in custom config management databases. They may want to leverage those. That's great. They can take the configuration, push it into the CloudVision portal to define what they want the configuration to be, but then leverage our APIs and automation to be able to push that change across the network in a hitless fashion. Or if you're using ServiceNow or some other ticketing system, you take the pending tasks, you push them up to that system, you get them approved, and only once they're approved and scheduled, you then go and run them, right? And again, this is how the CloudVision portal gets integrated into the larger problem of data center automation. So that's my quick demo. I don't know if there are any other questions.
You guys should talk more about transactions.
Talk more about transactions.
I'm not saying do it now. I'm saying just in generally as a company, you should emphasize that.
Oh yeah, I mean the ability to make changes in a sane way, where you don't have to think about the specifics of EOS on one side. You say this is what I want the state to be, and it just happens. And this is the power of the database model for sure.
Yep.
Yeah.
It's what we're hearing about controllers in general, kind of So this runs on virtual machines? You have redundancy?
Yes. Yeah. So this under the covers the CloudVision. So it's a clustered HA model. So it's 3 nodes. So it's and it's quorum election. You get n+1 redundancy. N+1 can go down, and then when it comes back up, another can go down. That's the redundancy model, similar to many of the controllers out there. Yes.
And if everything, they're all down, everything's fine, just no changes can be made to the network?
Yeah, so that's a really important point, because when you think about kind of the OpenFlow model, right, you have this now central controller node that has become central to any decision making you're having at the data plane level. And really that's not what we're doing here. We're trying to automate the management plane, not the controller data plane, right? And so this is all about how do I integrate with orchestration systems to provision new services, or to with management tools for pushing changes. And so that's right. If everything goes down, it's all you decide to take it all down because you just want to you need to upgrade it. Everything works fine, right? It's you can't provision new services, but given that you've taken it all down, that's kind of to be expected. So yeah.
So
good questions.
well, can't you just cancel to any particular box and issue configurations from there?
Oh, absolutely, right. And that's, another really important point. Nothing of what we're doing is changing the fundamental way in which you interact with in which you can interact with your box, right? From a scaling perspective and operations perspective, you need to be able to go network wide and not deal with each box individually and do things in an automated way. But at the end of the day, you got to be able to get on your box, right? The CLI is not going away when you're debugging, when it's 2 a.m. and you've gone on to try to debug stuff. You don't want to be told, no, those tools that you've been trained in, you can't use anymore, right? So all of that still works. This is the orchestration. And then, of course, from that box, you need to know, well, what did my orchestration tool do, right? You can't hide that from them as if, it doesn't matter. So
Yeah, I was just describing in the case of failure, let's say the controller is dead and I need to apply, ACL on the box. Is something urgent,
just change it, right? And from the CloudVision portal side, what you'll see when you go and make the next change is it'll say, okay, well, here's what your current config is, and hey, there's some commands here that I didn't push, right? Do you want those, or do you want to blow them away? And you have an option there's a reconcile button, which basically creates a new configlet applied to the device to say, hey, here's the configuration that's on the device that we're going to blow away unless you change. And then you can make any edits you want, or figure out, or you can decide, whoa, I don't want to make any changes right now. Somebody, my box is out of compliance and I didn't think it should be. In general, what we expect is that you start any sort of change window by checking, is my box in compliance? If yes, start to make changes, then push them, right? If no, figure out why, get it into compliance, and then go and make changes.
Awesome.
Yeah.
What about rogue changes? So you get your controller running. You got 10 folks on your team. You have a meeting with 9 of them and say, all right, we're using this controller now.
Yeah.
Number 10 doesn't show up, decides the next day to make a change on a switch. How does that get remedied?
Well, so, sorry, I thought you were going to talk about I thought you were asking about the person option, but you're talking about the controller. So
Yeah, you have the controller in operation. Somebody decides to make a change local on the switch.
Oh, yeah. Again, I think none of this supplants the standard process that people are going to go through, right? So you need to go and check before you push the change that nothing has changed in the device that you didn't expect. Then you push the change, and then you go and check that it's in compliance.
So you can still make local changes, even though
you can absolutely still make local changes. There's no locking you out of the CLI. And from an orchestration system integration, it's actually interesting. There's one important point is we separate the notion of underlay configuration and overlay configuration, right? So when the OpenStack integration decides, you know what, I need this VLAN to VXLAN mapping on this port because that VM has been placed there. That's not static configuration, right? You do write mem, that configuration doesn't go into the switch because it's not static, right? It wasn't inputted by the user, and it's something that's totally dependent on what OpenStack tells us, right? And so that separation, you can view those separately, and you can always make changes on the static side that integrate with that. So you can always make your own changes if you want to get things up and running, or to prevent something that shouldn't be happening.
Okay.
Yeah.
Well, what happens in the orchestration program when two people try and make a similar but not quite the same change? So with your ACL example,
Yeah.
two people go and set up a configulant, but they set the ACL differently.
merge conflict.
Because you had like a queue of like 12 things that happened to look like they were for different devices.
Yeah.
But would you see multiple entries for the same device for the different configurations?
That's a good question. Right now, what we enforce is the one task per device model, right? It's very tricky if you start to have people making different changes and then running them in different orders. And in general, what you're doing is you're making these changes and then applying them during a change window. If you're doing multiple changes to a device, it's because you wanted to change the previous one. We may expand on this further, but that's the model. You have one change per device, and so if someone comes in and makes another change, it's kind of additional to what was there.
You're adding to the same configlet, right?
Right, and so what would happen on that in the task? Before you run the task, you go and look at it and say, okay, is this what I expected it to be before I go and run it? And like, oh, that's weird. This other thing got added, and of course, there's role-based authentication to be able to prevent who can make changes. Also very important.
Right, and I'm trying. So I guess because the problem also becomes, though, when you have a single change per device, is now you may be bundling 4 configurates for 4 separate changes really into one push.
Yep.
If one of those fails,
it's all or nothing.
Because all 4 get rolled back, which is
but that's a choice. That's a choice that you get as the user, right? Because I think within your change window, you get to decide, okay, am I going to try to push everything all at once, or do I say, okay, I'm going to start with one, and then do the second, and then do the third, and then, oh crap, everything went wrong, and it's Sunday night, and the market's open tomorrow, so let me go and roll back to what it was Friday, and that's where the powered network rollback comes in.
But if you can only stage one at a time, then
that's right.
The pleasure of having 4 people stage changes and then someone overnight executing or scheduling a change one at a time.
I think in this case, we're trying
to
to get the simplicity of making sure that you don't end up with the weird ordering problem.
I can see that.
You can't use software to fix an organizational problem.
That's certainly true. Well, and
More process.
well, and a lot of the companies that we're going after have a lot of process already. So this is trying to fit into that process, not create a new one, right?
Just in terms of what Matt had alluded to in terms of making individual changes on individual objects, in terms of the next time you push a config change from a parent object to those child objects, would those changes be overwritten as part of a standard config that you're pushing, or does it leave those individual characteristics and changes in place?
So the CloudVision portal defines what the configuration should be. So you're using it as the database where you say, this is what it should be. And so if there's something on the switch you want, you can bring that in to say, okay, this is part of the definition of that device. But otherwise, the assumption is that you're using this to be able to automate and be able to say, no, this is what it should be, and I need to know when it's not this. And so we don't leave it there, right, unless you explicitly tell us to pull it in.